So you're gonna have to, your hands are gonna hurt when you're done, okay? But the textbook doesn't do a very good job at going through all these things. So chapter 7, quadratic functions. It actually might be called in the textbook, I think they call it relations and functions, but it's really all about quadratics, okay? I sometimes refer to them as quads, okay? A linear function has the equation y equals mx plus b, and produces a straight line. Produces a straight line. It has a degree of 1 because the highest power of x is 1. And I'm preparing you for grade 12 here when I give you some notes. Okay. Y equals mx plus b can also be written as y equals ax plus b, where a, that letter a, is the what we call the leading coefficients. So in IPR, you always use y equals mx plus b. But as we expand, like you looked at linear, then we're gonna look at quadratics now. Next year, you're gonna look at cubic. We switch from m to a, and that leading coefficient tells us a lot about the shape and which quadrants the ends will end up being in. So that's why I mentioned that. So this is just an aside, okay? Let's keep going. The quadratic function has the equation y is equal to ax squared plus bx plus c, and produces a parabola. And the graph more or less can look like this or like this. Okay, that's what a parabola, that's the shape of a horseshoe, right? I will say looks like a horseshoe. I will post the video anyways later, so just leave some room and then just continue where it has a degree of 2 because the highest power of x is 2. Highest power of x is 2. Note here a is the leading coefficient. You're going to hear this term next year, and it's very important to know where it is. Okay? So that's the next note is that in y equals ax squared plus bx plus c, comma, b and c can be 0. Just a note there. As long as a is not 0, like these two here could be absent, right? It could be 0 for b, 0 for c, but you need a to be a non-zero value for it to be a quadratic. A quadratic function will always produce a parabola which expands indefinitely. It points up or down, but never sideways. So here we'll just, you don't have to use a ruler for these. Just going to give you a bunch of examples of what a quadratic. I'm going to try to fit in 4 graphs side by side here. Two more down here. First one, it's going to look like this. First one, we can call it a quadratic. the degree of that function would be 2, because we know that a parabola is produced by a quadratic equation, and we know that quadratic equations will have a degree of 2, right? It'll be an x squared in there. This one here is nothing, and for us it's nothing that we can recognize. Here you have a quadratic again, degree of 2. This is a linear, right? A straight line, degree of 1. This is called, when it's, sorry, it's not the greatest graph. It should have been a perfectly horizontal graph, but this is called a constant function. It's just always consistently, right? The degree here is 0, right? Because it's just y is equal to a number. X has a degree of 0, right? X to the 0 is just 1. So x is not even in the equation, right? So a constant function has a degree of 0. So 0, 1, 2. That's as far as we're going to go in this course. This is nothing because it goes sideways, okay? It looks like a parabola, but it's nothing because it points sideways. We can't have that. And at the end of today's lesson, I can't really assign homework yet because you won't know enough for what's after this. I'm just going to talk about it because I will probably go right till the end. And so in your packages, again, the same one you already did yesterday. I'm just going to show you. There's another chart just like the one I made you fill in, right? So again, if you go to this booklet, right, there's one that's a little shorter than the one you did that I had assigned. Looks like this. So practicing the skill of rewriting, finding the intercepts, all of that one more time. But there's no graphing here or anything. So that's what I'm going to assign. If I don't get to it by the end of the lesson, then you know what to do, okay? That's that. Next page, for me at least. Okay, state whether the equation is constant, linear, quadratic, or other. And here I'm going to make a bit of a table. So, but don't worry, I'll kind of guide you through it. So we're going to have a column called equations. Okay. And I'm just going to give you all the equations first. So y is equal to 7 plus x. Here we're going to have y is equal to 15. Then we're going to have f of x is equal to negative 3x squared plus 4x minus 5. Y is equal to x cubed. Y is equal to 1 over x. F of x is equal to x minus 2 squared plus 3. Y is equal to x minus 5 times x plus 3. So once you've written all these down, I'm going to make my column there. I'm going to call this degree and type. Type of function. So a reminder, right? There's a video out on how I did the table, the one I assigned for homework. If you're not comfortable with a calculator, go to it, okay? You need to become really good at it. And fill out that table, the second table for tomorrow. I will also post the answer key to that, okay? So the first one here, what's the degree there? You look at the x, and that one has a degree of 1. So this one is just a degree of 1, and it's a linear function. Okay. What about the second one? Well, technically it has x to the power of 0 next to it. So the degree is 0, and it's a constant function. We're going to kind of move away from linear and constant and stick more with quadratics, but you still need to know the difference for next year. Then this one, f of x, don't let that scare you. It's the same thing as y, but it's written in a different form, right? So we look and we have a degree of 2 there. So this one is a quadratic function. This one has a power of 3, right? So the degree is 3, but it's none when it comes to what we know so far. We call it none or other, sorry. I used other on the description, so I'm going to go with other. This one, x is in the denominator, so that's actually, I don't know if you remember, if x is 1 down here, when it comes up to the numerator, it goes to -1. Do you remember that from IPR when you bring something up? So the degree is actually -1, and it's just other. You don't have to worry about that one, but I just want to show you that. Next, you have another f of x. This could be g of x, k of x, it doesn't matter. Variables can change. It's still y. And notice how it's x minus 2 to the power of 2. Out of this here, if you were to expand it, you would get an x squared out of that one. Do you remember that? So because of this, we can just say without working it out that it has a degree of 2 and it's a quadratic. Okay. Basically, the second one here, I don't know if you remember distributing out, but x times x would give you x squared. X times 3 would give you 3x. Minus 5 times x would give you -5x. -5 times 3 would give you -15. So you still have this there, right? So that means that this is still has a degree of 2 and it's still a quadratic. Okay, so if you see a power of 2 in brackets or two binomials multiplying, you know you're going to get an x squared out of it, which is a degree of 2, and we call those quadratic. Properties of quadratic functions. And this is going to be long, but it's very important. And we know that quadratics always look like this, or a variation of it, I should say, but in general, we say that. Number one, the direction of the opening is determined by the value of the leading coefficient, and we call that A, okay? Which is always in front of the x squared term. Like let's say the x squared is at the, for some reason they wrote it so that the x squared is at the back of the equation. Don't let that fool you. Whatever is in front of x squared is the leading coefficient. It's not necessarily the first number that shows up after the y equals, okay? Okay, so here I'm going to give you some examples. If A is positive, it opens up. That means that your resulting parabola is going to look like this. Okay. So examples of that, y is equal to 2x squared, y is equal to 3.75 x squared minus 2. It gets wonky because we have calculators, right? Y is equal to 50x squared plus 7x. So these are all variations, right? And in all of these, if you look at the leading coefficient, where's x squared? Is right there. What's in front of it? That's the leading coefficient. Again here, that's the leading coefficient. So for all of them, right, A is positive, points up. If A is negative, it opens down. How would you know that? If it's negative 2x squared, y is equal to 18x minus 1/2 x squared. F of x is equal to negative 7.81 x squared plus 9. There's a negative 2x squared. right? -2, that's the leading coefficient for that equation. On this one, it's a little tricky. X squared is right there. So it's -1/2. Over on this one, you have -7.81. Let me give you one more. Say what, right? That, you're going to get an x squared term out of this. We still call that our leading coefficient. Okay? That's still going to tell you whether it's going to be pointing up or down. Okay. Before we go, I'm just going to show you, let's just try a basic example. Okay. If you grab your calculators, go to y equals and clear whatever is there for now. Go to y equals and then clear all your equations. And let's just give this a try right here. Type in 2x squared. So 2x to the power of 2, right? You have a little x2 button, right? Then go to the second one and type in -2x squared. So negative, remember the negative in brackets, 2x to the power of 2. And let's hit graph. There are your two quadratics. And this is way too zoomed out, so I'm going to go zoom 6. If you want to do the same, go for it. It's a little bit nicer there. So you essentially have the same, they look exactly the same, but one is pointing up and the other one is pointing down. Okay. If you want to practice, right, you could type in this one here. I'm going to go y equals. My third equation, I'm going to go 3.75 x squared minus 2. I'm typing in this one up here. Hit graph again. And we expect it to be pointing up, and it does. See? So just to give you a visual, that's what it is. We're going to stop it